Okay, so in this problem, they have us looking at the cross braces on the gate below, and they want to know what we can say about the angles 1, 2, and 3. So let me just label this diagram. Here, a cross brace, in our case, is actually a bolt, and it's right, these are zigzagged, or they cross each other at an X to support the other beams on the fence that you're looking at. So these are the two cross braces they're referring to. And the angles 1, 2, and 3 are right here. 1, 2, and 3. So the idea, when you get a problem like this, is to try and think about how this might relate to what you know about angles and lines. So here, those two cross braces are in fact transversals. They're lines that cross other parallel lines, and these pink lines I'm drawing in right now are the parallel lines. And here we have another set of parallel lines, the vertical ones here, 1, 2, which also eventually cross both transversals. So really we're dealing with a problem with transversals, and angles 1 and 2 are between 1, 2, and 3 are on the interior of the vertical parallel lines this way. So they're between this parallel line and this one. And if we ignore the middle parallel line, they're on the interior of these two parallel lines as well. So I would, if I was describing these angles, refer to them as interior. I also noticed that here this might be an approximation or it might be exact, but it depends on, of course, how the gate is measured, that most likely angles 1 and 2 form this right angle here. So I would say that, first of all, angles 1, 2, and 3 are all interior angles. Interior angles. That's the first thing I would say. I would also say that 1 and 2 are complementary, and oh boy, complementary. Complementary and a complement are not spelled the same way, and I can't remember which one's which. I'm sorry, but that means they add up to 90 degrees, as opposed to supplementary, which means they add up to 180. So angles 1 and 2 are complementary because they form a right angle, and I also know that 2, right, and 3 are what? Well, 2 and 3 are equal. 2 and 3 are equal because they are alternate angles. They're on opposite sides of this transversal, and they're equal because they're alternate interior angles, right? If you want to think about that, so I would say that 2 and 3 are congruent because they are alternate interior angles. They are alternate interior angles. Now, if you are looking at this diagram, there are other questions they can ask. Let me just kind of simplify this diagram below here. So if I just resketch, this time we have our 1, 2, 3, 4 parallel lines and our transversals. Again, I'm ignoring that middle parallel line. We could talk about it, I don't want to get into that right now. Here, right, let's just talk about all the angles we can. So let me just extend this line a little bit further here. Oops. Try one more time. Extend that. That's better. Okay, so imagine this one transversal is extended. The same here. Oh, sorry, it's a little bit off. Okay, so here, right, we had angle 3 and 1 and 2. Well, 1 and 2 are complementary. 1 is equal to 3, and 2 would be equal to 4. These are also interior, alternate interior angles. Again, they're on alternate sides of a transversal, and they're on the inside of two parallel lines. Also, let's say 5 would have to also be equal to 4, right? Those are corresponding angles. If you think of these angles around in this area versus a snapshot of these angles, and we were to maybe take this area and slide it down here, if we literally cut this out and slid it down here, 5 and 4 would fall in the exact same location. So they're corresponding. Just as maybe 6, right, and 7 are corresponding, right? Now 2 and 1 correspond to 8 and 9 here, and then 10 and 11 would correspond as well. And if you kept going with this, we have vertical angles that are also equal. So as a quick sample, and my diagram's getting kind of messy here, so we'll cut this short, but let's say 6 and 10 are equal. They're vertical angles. Also 7 and 11 are equal. So here I know 10 equals 11. So since 6 equals 10 and 10 equals 11, 6 and 11 are equal. And those are called alternate exterior angles. Now, alternate exterior angles are always congruent, just like alternate interior angles are congruent. So this angle is on the outside of the parallel lines on one side of the transversal on the left, and this angle is also outside the parallel lines that we're looking at on the other side of the transversal, hence the name alternate exterior angles. So that might help you with some of these types of diagrams. Anytime you get a diagram and they're asking you about angles, try to think how it might relate to vertical, complementary, supplementary, and alternate interior or exterior angles. Thanks.